and start the Q&A. Typically, I would pose some questions about maybe a seed question or something, but I think that given the broad scope of what we've covered already, I don't know if that's really necessary, because I would ask something like, what stage of the implementation are you at? I think that, or something on that order, it's pretty well covered. I think you guys can see that both of these companies have progressed, have done their homework, and implemented it at a fairly high scale. So let's just go ahead. Do we have somebody that's got the mic over there? We got one here too. We can watch that. So I'll just go ahead and open it up. We've got a fair amount of time left.
All right, I'll be brave enough to start it off. Ralph Rio, AOC Advisory Group.
Thank you, Ralph.
You're welcome. Some of you, I think, were talking about digital twins that were math models. And some of you, I think, were talking about digital twins that involve 3D visualization. And I was wondering if you would be willing to compare and contrast. When is just a mathematical model okay, and when do you need 3D visualization? If anybody could comment on that.
I can maybe start it off and let them finish. So a digital twin is really built for whatever purpose you want it for. So in our case, the visualization was not something that was part of what we were looking at or wanting. So there was no need for that. So I think this is one of the watch-outs with the digital twin. It's a very broad spectrum, and you have to choose the size of your sandbox based on a number of...
Could you get a little closer to the microphone?
Sorry. What I was saying is that the spectrum of digital twins is very broad, and you have to choose the size of the sandbox that you want to play in because it defines scope, cost, timeline, and the lifecycle management of it. So my guidance is, you want to make a digital twin as small as you can get away with. That help?
And for us, I think ours was more on the visualization side. That was very important to us. I think two of the key things, maybe we didn't go into a lot of detail with, are we're actually training operators today in that digital twin. So the operators that will begin operating that plant in March of 2023, they're already doing operator rounds in the virtual environment. In the digital twin, they're actually doing their rounds every day. You had up the construction site. The meaning of that was, so for us, the digital or the photographic visual element was very important.
Yeah. And I would also maybe just add one more. So we're really looking at two totally different applications. Our machine is 25 years old, and it's about optimizing a process that is already fairly mature, but now looking to use digital twins to get that last incremental optimization opportunity. It's very different than a greenfield big expansion.
If I could just expand on it just briefly. And it's been pointed out by the folks here presenting already, that we can, a digital twin model, and to Ralph's point in his questions, it's a great question, because if we go back to traditional CAE type simulations, I mean, that's based on physics. So we have visual models based on graphics, based on 3D. We have models based on physics, and when we build a digital twin, if we're trying to capture the process and use the data to actually understand what the variations in the process is, how we can improve the process and optimize and so forth, we need visualization, but generally speaking, we need a combination. We need the physics-based models, and we need a visual model to actually capture the environment that it's in. So it can expand all the way from a visual model may be very, very helpful for operator training, but if we're trying to capture what the process is really doing and monitor it and improve it, we're probably going to need a physics-based model. So it's let's just put the digital twin in its context. It's a lot of different kinds of models based on technology that's been around for a while and based on new technology going forward.
And some of those models can coexist and some should, right? So, you may need the physics-based part of the model in order to appropriately train the operators to coordinate with their control room counterparts. So the field and the control room are accurately following a process, not just a fake process for the real world.
Yeah.
So I think that builds on what you were saying.
Yeah, you want to improve the process, but you might want to train the operator at the same time.
Yeah, you can get both.
And you can get both, yeah.
Oh, I'm going next, Seth. Sorry. So, all right. So I'm Jacob Gleason. I'm with Chevron. My question is for Brian. I support capital project development as well. When do you guys, how are you building? You said we a lot, right?
Yeah.
We're using this during design and build phase.
Right.
This is not traditional, right? So and I'm assuming you're not self-performing your engineering, procurement, and construction of these facilities, that you're working with a contractor or a series of contractors. Are they building the models for you? And if so, how are you sharing the models as you're going through design build? And what did you do to get your contractors to actually produce this? You have to give them specifications on what you want delivered and when you want it delivered and that sort of thing. Could you expect how are you building this thing out during design and build?
How am I building it out during design? Okay, so it's actually happening during. It started during early design. And feed. We're also in at the point where we're paralleling paths. So we have issue for construction going on, while we still have issue for review and issue, and design. So what we do is we do exactly what you said. It is a little bit of a mess. That's why standards become extremely important. Standards in nomenclature, tags, everything. Standards all over the map become very important. You do have to tell the contractors exactly what you want, put it in the contract language or you won't get it. And you have to develop, what we did was we developed an ad hoc handover. Not the traditional, it's a rolling handover. Right, so that was especially important for the equipment suppliers. They're not used to doing any kind of 3D handover at all. You just buy a piece of equipment, it shows up on a pallet, or parts of it do. So it's been learn as we go. We've been flying that particular plane as we're building it and learning. That's a different talk. Best practice on that rolling handover is a different talk, but it's one we need to nail down and have. Does that help at all?
Oh, it does. I've been doing this for a long time, and I was like, man, and I worked on the contractor side as well.
Mm-hmm.
So
It's a mess.
This looks like a challenge, right?
Yeah.
Because, we had a hard time just doing rolling handover on documents, like every Friday sitting stuff. You guys are talking about rolling handovers of an in-flight, in-construction digital twin that eventually you're going to hand over to operations, and you hope it's complete, right?
Right.
All your procurement tie-ins and everything else.
Right.
And it looks like a daunting challenge, and I wanted to pick your brain on it.
Hi, good afternoon. Seth Taylor, also from Chevron. We're becoming very vocal all of a sudden. So thank you for the presentations. I had maybe a couple counterpoints to, Brian, a couple things you said on your last slide. First one being return on investment agnostic. And I was a little surprised to hear that. I suspect it may have something to do with the fact that you had leadership that was committed to doing this and had decided we're going to go do this, and perhaps you weren't asked to give that sort of, killer, what's the value delivery that you're doing from this?
That's correct.
Be curious to know, certainly our perspective within Chevron and talking with peers around the industry is we have very different experiences with getting commitment for digital twin without a compelling business case based on all the competition and prioritization of funds. Second comment had to do with starting with greenfield facilities. I've done digital twin work at one of our newest assets within Chevron in Australia and one of our oldest, where I'm based in El Segundo at a refinery in California. And I just want to provide the counter perspective that doing it at a very new facility, when you go, if you're a company that has legacy, global assets, if you're successful in a very new facility, the immediate question is, well, Australia can do it because it's new and they had billions of dollars of investment, in the recent past. Having success in a legacy facility gives you legitimacy and credibility to demonstrate a new technology that a lot of the other facilities or business units around the globe can look at that and say, if you can do it in a 110-year-old refinery, you can do it anywhere, right? So just a counter perspective that when if other companies are thinking about where to start with this, there's a lot of credibility you get from doing it at a brownfield legacy asset.
But you wouldn't disagree that it is more difficult to do in a legacy asset, would you?
Not necessarily. I think there are unique challenges to brownfield, but there's a lot more, let's just say there's a lot more use cases, right? There's a lot more opportunities to demonstrate the value of a digital twin for an asset that's operational. And I think some of the other speakers in the session today were speaking to some of those opportunities. I certainly understand it's cleaner to do it in greenfield, and you can, there's probably less, legacy data challenges coming your way with that.
Yeah.
But I would say there's a lot of opportunities to demonstrate a broader set of use cases in a brownfield.
Well, I know my counterpart, Steve, who is leading the brownfield effort, is listening intently to you, and he just loved everything you said.
Yeah. I think with the right leadership, the commitment can be more of a philosophical decision, but in some of our industries, I think the business folks tend to make some of those funding decisions, not necessarily people who really are passionate or get the technology, right? And so anyway.
I think we had a question there.
Voice was carrying great.
All right, there we go. So for the greenfield, I fully understand the value proposition on having a digital twin. But once you're in operation, how do you really expect to maintain your digital twin as modifications are made to the plant? We have a digital twin on a greenfield project, and that is one of the biggest watch outs and questions that we have is, how do we seriously maintain this every time, we have a pump change out, or we add a new valve, or we add a new whatever. It's a lot of maintenance to maintain a digital twin. So can you talk about what your thoughts are there and what your strategy is?
I'll start and you can finish. So this particular facility, we manage OSHA 1910 at our Kingsport facility a little bit different. We go fence to fence. So management of change, anything that's changed out, we have to update that. We have to update the drawings. And so we're linking that back to the model. So our intent is to maintain and keep this up to date through that MOC process, linking the MOC updates into the model. We don't do that at all of our facilities, so that's a challenge that we'll have to look at as we move beyond the Tennessee facility. But for this one, that's already a thought, and the intent is to keep it up to date. Because we want to optimize once it becomes brownfield and continue to see better production rates and debottlenecking opportunities.
If I can comment on that as well. So I believe this is one of the challenges we see as important, that vendors like Siemens will have to come with better solutions to sustain and maintain the greenfield when it becomes brownfield, and also to speed up data acquisition and building up a brownfield facility more easily, because you have lots of opportunities there, but it's still challenging to bring all this data in one, let's say, complete digital twin, 2D, 3D simulation, everything from the same frame, right? So this is something we are investing a lot to make your life easier in this area.
I actually have a follow-up to that. Excellent question. Is similar from a robustness of a PLM. When you look at that product lifecycle management back into feedback to design, if you're looking from an operational perspective of equipment that's already there, as kind of Vivek and team have addressed in their digital twin, but it's a very different use case for Eastman, right? As you've got a lot of construction inputs, and we're going through that too. I work for Purina, and we're building 2 new factories. So we have a lot of input and feedback to design, but we also have the use case of optimization, either from process or quality. So from that PLM perspective, how required is it to have a robust process, either feedback to design or feedback to improvement of operations, so that your digital twin itself doesn't drift too much from reality? Hopefully the question makes sense.
It's sort of like following pi data, you know, and the process optimization group does that work. I don't know that I can answer that yet. Does anybody else?
Stumped him, all right.
Maybe I could jump in on that one a little bit because you bring it up from the perspective of PLM. So getting back to the basic concepts here, and I was trying to make the point that yes, you're using your PLM systems obviously to model, to build a CAD model of the product or the asset or whatever it is, the part that you're building, that you're going. And so in today's, let me back up for a second. In today's design environment, you have simulation, validation, simulation, CAE type platforms that enable the design engineer or the designer to basically go into a concurrent mode instead of going through the complete design and throwing it over the wall to a stress analysis to a CAE type expert. The platforms are robust enough that as they go through this design process, and they're basing their design on fundamental fit, form, and function criteria, there's a concurrent process going on where the validation, in other words, there's a democratization, if you will, of using these expert systems for validation of CAE, much more than there was in the past. Now, take the element of the digital twin in that case. The notion of the digital twin, as I said before, doesn't really exist until you manufacture that product, that asset, and put it out in the field. And so I was trying to make the point that the configuration was extremely important. The model that was built in the PLM system and the CAD system is not static in the environment of a digital twin. It is a dynamic model because it's subject to a constant change based on the robustness of the data or the amount of data that comes in from the product or the asset that's in the field. And that's really the entire notion. So I don't know if I'm answering your question, but from the perspective of PLM, well, let's put it this way. There's a reason why the PLM suppliers that have the technology for design, for 3D CAD design and so forth, there's a reason why the digital twin, the implementation of the digital twin is coming from that industry, because they have the biggest part of it, one of the biggest parts, which is the virtual side. They've always have. So
I can maybe give a different perspective. So one thing to keep in mind is nothing needs to be written in stone. And what I mean by that is you may have a broader scope for the digital twin application out of the gate. But as the years go by, you may choose to maybe downsize the scope. Maybe at that point, the visualization for safety is less of a need because you've built the building, you've built the facility. I'm just saying that's a maybe, right? So you could choose to sustain what you can afford and what you believe continues to provide the business proposition, and expire other elements of the digital twin as being now obsolete. You can mothball it so you can rejuvenate it if needed again. But these are some of the life cycle strategies that certainly, I think we would pursue if we were doing something as big as that.
So this is Michael Hoteling from ExxonMobil. I may have an opposing view to a couple of those comments that were made. I guess from a key point here is that 80% of the use cases that you showed in terms of the value of that digital twin, we would argue that you actually don't need an engineering model to support that.
May I add something though? To color those use cases, that's just what I'm getting today. without trying.
Agreed.
That's not my end goal.
No, agreed.
Okay,
The point is, we're talking about rich contextual information of your asset.
Yep.
And that doesn't necessarily have to start with an engineering model.
That's true.
Engineering models from company A, B, and C are not the same, right? You know, depending on your engineering firm, in terms of the data and richness that you have, there is a wide spectrum of exactly what you're going to get in that digital asset. I think from a sustainment standpoint, one of the challenges that we have as an industry is actually finding a hybrid by which, you know, you talk about reality capture or, you know, visual capture and augmenting that with an underlying engineering model that may be seamless to the user. And I think that's part of the journey that we're continuing to work on and work with a number of suppliers to get out of this paradigm that 3D digital twins have to start with an engineering model, because I would argue that that is not the case.
So I agree with you, depending on the application. And as Brian said, this isn't the end state of what we're trying to do. We've also done proofs of concept of brownfield sites. We generate our own power at this facility. And we've done some examples in our powerhouses where we use laser scan. We do a laser scan and then a photo image of it. And we just have a very, very simple model, not even a 3D model, but we can overlay the new design over the reality of the situation there with the laser scan. And you can instantly see, oh my gosh, we're not going to have room now to move equipment in and out. And while it looks good on paper, when I start trying to walk through this, it's not going to work. So I think that's a great example of using different tools than what we maybe showcased here to get that desired effect.
I would agree with your premise from the perspective, from purely an operational perspective. But if you put it in the context of, say, a maintenance technician, the 3D model is simply a tool for them to use. They may only need all the operational data that the sensors and all the smart intelligent end devices are picking up off the asset to effect a change, effect a fix, or repair the problem or optimize the situation. But they can use that 3D model to actually have a visualization as a tool. Just simply go in there and fix the problem. I mean, rather than trying to pour through a bunch of paper or whatever they've got, or manuals or so forth, you know. And this is, in other words, augmented reality, that's really what I'm talking about, is a tool. And it kind of makes your point is that you don't need a 3D model, except maybe that really helps the maintenance technician a lot. And so this is why that aspect of it's being implemented a lot, you know. Oh, and it's going to change. It's going to vary. It depends. So anyway, I think we basically beat this to death, and we're a few minutes over and everything. As is usually is the typical case in a technology like this, we could go on for the rest of the evening on this. But I thank all of you so much for your participation. And the best part of these sessions is going through the Q&A period and getting some real world perspective from the audience and so forth. So I thank you very much, and I thank the panel, and I thank both companies, both Kimberly-Clark and Eastman Chemical.
Thank
You guys are great, and I think you've both given all of you have given some great examples of where we're going to go. And this is definitely a journey. You know, and it's one of the things. So thank you.